processing and the communication aspects of the Internet of Things, which are more hardware based and maybe more electronics based, but ultimately all these things are the most important pillar in collecting data for the computer science or the analytics part of the domain of this domain, because ultimately all your data is generated from these devices, and then we can use it to for different purposes. So basically, when we discuss these things, I will try to keep it simple for both sides, so it is not very hardware centric. This presentation will be interesting for both. Also, for someone who would like to take it as a hobby or as a project, it will not be a very difficult thing. Also, on this platform, I wanted to invite you. We are creating our own Internet of Things lab in the college. If you have any ideas, or if you have any solutions and you want their like implementation, or if you need any knowledge or some training about them on how to implement them or how to incorporate Internet of Things in your projects, you can contact me or Mr. Hussam, and we will be more than happy to guide you. We have a list of equipment also, which we just recently imported. So we will also share the list with all the participants and also on the college level. So you know what is the stuff available in the college and what type of solutions you can make. It's both for like the whole college, so from information systems, from computer science, for computer engineering students. Everything is very simple. You can easily use these solutions in your project. So starting with the introduction, generic scenario, I will start from the concept of this Internet of Things. I will give you a short concept on what Internet of Things basically is. We'll go through the basics of embedded systems, because the brain or the heart of these Internet of Things is the embedded system. Then we will look at what are microcontrollers, what is basically an IoT, its history, its potential in analytics and artificial intelligence, the basic architecture. Then on this hardware side, what are the processing platforms, what is the IDEs that we use, the sensor, the actuators, the communication platforms or the communication protocols that are used. After this will be followed by some cloud information, how we can store this data on the cloud, how databases are being used, and what is a dashboard, how a dashboard is created. Then some of the aspects of IoT that we can find in the smart cities, and then the latest push in Saudi Arabia related to the IoT Vision 2030, followed by some examples and the future, whatever is there in the future. So we'll discuss all these things briefly, not in details. So starting from the concept of IoT, the first thing is, before the Internet of Things, we will discuss what is a thing. A thing is just a random substance, whichever is there on your left and right, which is not connected to the Internet or which has no IP address. It can be a ballpoint, it can be a bottle, anything around you is a thing. And once it gets connected on the Internet, we call it an Internet, which is composed of these things. But for that, of course, we need to sense this thing, what is it, and then we have to communicate it on a cloud or just put it on a cloud so anyone can access it or another thing can access it. I came up with an idea last night, so I thought I will add this thing. Let's say our thing is a gas container, which is most of you have seen in your homes. And the problem which we are going to discuss is what happens if the gas container is empty at your home. What is the next step? The next step in a normal scenario is you just remove it from your stove and you just take it for the refill. Or the second option these days is you use an app. You just whenever it is empty, you just go to the app and you order it, and the company will bring it to you in 1 hour or 2 hours or whatever time it is. The problem is you still will go through all this process. It will get empty, then you will say, oh, this got empty, now I need to fill it. If you are in the middle of cooking, you will have to remove it and you don't have any other option but because there is no meter or no gauge connected to the cylinder which can tell you how much is it left. One easy way to do it is to measure its weight. Like normally if it is empty it will be maybe 10 kg, if it is full it will be 20. So if it is 12 kg it means there is still 2 kg of weight left. So this is the first case. For example, we weigh it and we see that okay, before it is empty we can check it, but the problem is still it is a repetitive process. You will have to measure it all the time before it is empty, because you need to check it every 10 days or 15 days what is the current status of this gas container. So what is an easier option? Okay, so about this scale, what is this scale? This scale is basically an embedded system. It has an input, it has a single output, like these are 4 pressure sensors. Whenever you stand over it or you put some weight over it, it will detect the pressure, and based on the pressure there is a microprocessor inside which will calculate how much is the weight of this container, and it will display you the weight. This is a form of a very simple embedded system. It is a digital weighing scale. There are also mechanical weighing scale, but we are talking about a digital weighing scale which has an embedded system. It has electrical sensors. It detects the pressure, and based on that pressure it will give you some output which is the weight of that container. Another option can be we replace this scale with a Wi-Fi scale. You would have seen them in the pharmacies these days, which will give you your weight data on an app. So whatever thing you put on it, the weight will go to the app and you can see it from there. It will also be uploaded to the cloud. You can have the data of all the like every day or 2 times a day, 3 times a day, whatever it is. Now consider this: we put this cylinder on top of this scale and we program it to check the weight of this cylinder every 1 hour or every 2 hours. And once we are measuring this weight, when it is empty, what we can do is we upload this data using our home Wi-Fi router or anything, because the scale is Wi-Fi enabled. It will of course connect with the router. From the router it will connect with our phone, and it will also connect with the cloud for the company who designed this scale or whoever made this machine. So it will upload this data to the cloud, and from the cloud we can automatically request the application or the company who is responsible for bringing us the gas cylinder to bring it to us, because it is going to be empty soon. Now what we have done is we have automated the whole process. We have an automated cylinder measurement system which is taking the weight of the gas container, and it is automatically connected to the cloud, and it is automatically accessing the company and telling it that okay, now I am 10% left, now I am 5% left. If a company has smart cylinders, if it can give smart containers to all the people, it will generate a lot. It will generate a lot of data for it for help, and it will maximize their revenue. For example, if there is a big company which works on like 1,000 or 2,000 containers in 1 day, so if they don't know how much is going to be our demand today, they will just have like maybe 2,000 of them. They will order them in advance, but maybe all of them are full. Maybe no one needs it. So it is just a guessing, and based on their random demand, they are arranging their products. But if they know, if all their products, if all their gas containers, if all the homes are connected to their server, they will know what is the current status of which cylinder or which container. And whenever most of them are empty, they will have already a new container in the backup, and they can provide it to the customers based on whenever it is going to be empty. So what we did was, we are not only measuring the weight of the cylinder, we are also communicating with the app. So this is the actual Internet of Things, in which things communicate with things. Basically, before that, we had an Internet of people. We were people connected on phones, people connected on people connected on laptops or PCs or servers and all these things, but they were talking to the things they were ordering, like tele operations in which you have a doctor maybe sitting in the US performing an operation over here, but it was a person supervising and here a person getting the some stuff. So basically the idea of Internet of Things is to have the things which can communicate with each other. They can tell the status to each other, and based on that status and with the back end of the artificial intelligence, they can perform some operations. So this one is a one-way operation. It is only measuring the weight, but there is no actuation. What is an actuator? Actuator is the opposite of a sensor. A sensor will sense the data and send it to the cloud or to you or whoever. An actuator is the opposite. It will take your input and perform the output for you based on that input which you gave it. So here we think of, we consider another thing, which is here. So the data is connected to the cloud, and then from here the user can access it. Now we have a temperature sensor, which is also connected in your kitchen. Now this is the concept of actuation. We have a fire alarm. It says there is a fire. The first thing we need to do is we need to turn off the gas from the container. So what it will do is it will connect with my Wi-Fi router, and it will, if it is a Wi-Fi temperature sensor, it will connect with my Wi-Fi router and ask it to like perform all the operations which were required when there is a fire. In that router, we should have a connection for maybe an electronic switch, which you can see on your left side. This is a switch that works on Wi-Fi. You can send it commands. It will turn on the gas or a liquid or any flow. It is just a flow switch or a flow valve which will work electronically. So based on if there is a fire, it will electronically shut out the gas from the container. So this is a complete scenario of an Internet of Things. You are detecting the data, you are measuring the value, how much is the gas left or whatever, and sending it to the cloud. And from the cloud, the data is automatically reaching the companies. They can arrange their supplies and all these things based on that. And also, if there is a fire, the temperature sensor can automatically connect with the shut-off switch and automatically decide with all the like ask it to close or turn on. If you think of this whole scenario, there is no human involvement in it. The human is only the one who is cooking on the gas, and he is not interfering in anything. All the things are being done automatically from the device to the app, and from the fire extinguisher to the or the fire alarm to the shut-off switch. Everything will be done automatically. This is the basic idea of an Internet of Things system. We talked about an embedded system, which was the wing scale. Before we go to into the details of IoT, we will just a little bit have an idea of what is an embedded system. An embedded system is basically a very simple system which has some hardware and a little software component. The purpose is to take an input and to give you an output. Your electronic thermometers, which you see a lot these days, is an embedded system. It has an infrared sensor. It will detect your temperature, and it has an output in the form of a display, and it will show you the output in the display. But it is purpose specific. You cannot watch YouTube videos on your thermometer, or you cannot play songs on it or something else. You cannot do calculations using this. It is a purpose specific system designed specifically only for measuring the temperature. The good thing about it is that it will have a simple solution. It is very simple. It will take less power, and it will be very good at the task which it is assigned to do. It is not like a general purpose microprocessor that you can program it to do anything. So in that case, you need a very powerful system. But here we need a processor which is very simple, whose processing power is less, but who can do that specific task quite quickly. The RAM and the ROM will be very limited, and that is the heart of this system. Other than that, we need some inputs, like in case of your thermometer, it will be the temperature sensor. If you have your car remote locked, it will be the buttons in your car remote lock. You have two buttons to lock or unlock your car. That is the input. and the output is the radio sensor signal that it will send to lock or unlock your car. So that is the output. It sends a signal. In your case of your TV remote buttons are the input, and the infrared signal which it sends is the output. So okay, so in case of an embedded system, you will have some software, a combination of inputs and outputs connected to a very simple microcontroller. We will discuss what is a microcontroller. Examples are like this robot you could see at the on your screen. It has obstacle avoidance sensor, 2 of them. On top of them, there is a black color buzzer. It has 2 tires. The output of this system, this embedded system, is the tires. Based on the input which is coming, it will sense the input, and based on that, the output will be the rotation of the tires. So it will keep on moving, and whenever there is an obstacle in front of it, it will stop and change its path. So this is just a simple embedded system. It has no, like, there is no complicated stuff. There are only inputs from the sensors which are connected directly with the microprocessor. The microprocessor then instructs the machines or the motors which are connected with the tires to turn it left or right, and there is a battery to move it. So there is nothing complicated in it, just a simple code which will detect the inputs, and based on that detect the obstacles, and if there is an obstacle, it will change its course. That's the total purpose of it. We'll discuss some more examples of a basic embedded system. An embedded system is there in your refrigerator. It will detect the temperature on whatever you set. You set the temperature. If the temperature is high, it will turn on the refrigerator compressor. If the temperature is low, it will turn off the compressor of the refrigerator. Also, there will be a door sensor. If someone opens the door, it will turn on the light. If you close the door, it will turn off the light. So these are 3-4 functions of this complete system, embedded system. But the basic thing is it has just 2-3 sensors connected to it, like the door sensor. It will sense the data, and then there is an action which is the light. So it will sense the door, turn on the light, then sense the door, turn off the light. So this is a very simple example of an embedded system which you all have observed. We see a bit complex embedded system over here in a quadcopter or a drone. You have 4 fans which are the outputs. The 4 fans will work based on the RF link. Over here you can see the RF link. RF is a low frequency, high range transmission technology. It's not needed over here, but just for an idea, it's just like we have 2 technologies here for the communication, Wi-Fi and RF. Wi-Fi will be used for the camera data, high data rate. We have RF for low data rate, which will work with our controllers and all these things. So if you are a person who is designing this thing, you just need a processor. You will connect it with 4 motors. The speed of the motors will be connected to the RF. It will take the input from the remote control and receive the input, and based on that perform the operation to send some data to the 4 electronic speed controllers, ESC 1, 2, 3, 4, which are connected to the fan to move it left or right. Everything will be done in the code. The hardware is very simple. You will just connect 2-3 wires to all these things, and that is done. The rest of the thing, everything will be done on the software side in C or in Java, whatever language is preferred. This is a common embedded system. We have some memory connected to it to store the data. We have the GPS sensor which will sense your coordinates. We have the remote controller for RF. We have a Wi-Fi link to send you the data and all these things. This is embedded system, a bit complex compared to the remote control or another thing. This is a car embedded system. It is much complicated, and it is composed of thousands of sensors at every door, in every tire, in every light, in every brake, everything. So, but the same purpose, it will serve the same purpose. You will have some input from some place, and that input will result into some output. If you press the brake, this is your input. It will detect this motion, and your red light on at the back will turn on. That is the action. The rest, there will be just one simple microprocessor which is collecting all these data, and a lot of different functions or different libraries are working to deal with each one, every item in this system. We discussed a lot about embedded system, but we did not talk about what is an embedded system doing, how the embedded system is doing the processing. Is it a computer or is it a device? What is doing all these things? Who will run this code and who will perform this operations? Who will take these inputs and who will perform these outputs? So the thing in embedded system which we use is called a microcontroller. The difference between a microprocessor and a microcontroller is that in the black image you can see on your right side is the microprocessor, on the left is a microcontroller. A microcontroller is a simplified microprocessor together with the RAM, ROM, input and output ports and everything in a single IC. It is just like your Intel Core i7 or Core i5 or whatever, but for those microprocessors to run, you need a motherboard, you need some RAM, some ROM. All the things are separately connected on the motherboard, but it is powerful. You can connect your hard drive with it, everything, and then it will run. A microprocessor cannot run standalone. A microcontroller, which is a smaller version with a less powerful microprocessor in it, can run without any external devices. So you can see the chips at the bottom. These are all microcontrollers. They come in different sizes, different processing power, different memories, different operating voltages, depending on your needs. Now, for example, you see a large microprocessor. You will not put it in your car remote controller because you have just two keys. You need to take input from two keys, and you need to send the output to the radio controller, which will turn on the car or unlock the car or lock the car. But similarly, you cannot use the small one in a drone because drone has a lot of inputs from the camera sensor, from the Wi-Fi sensor, from everything. So it will have only 2-3 pins which are not enough. So this is the basic idea, the difference between a microprocessor and a microcontroller. A microcontroller is a very simplified version with all the things connected in a single IC, and that IC is enough. Sorry about the complexity of these things. This slide and the next slide will be a bit electronic centric, and after this we will move to the generic stuff and the easier stuff. So this slide, you can see a microcontroller. This is a very simple microcontroller circuit that is enough to run it. You have the power circuit, you have a reset button, and maybe a light for testing. This is the complete circuit of a microcontroller. Before we design or connect it with our sensors, with our output actuators and all these things, this is a common thing. Before starting, you connect all the basic circuitry, 5-volt and ground, or you say positive and negative from your battery, which is connected, so it starts working. It needs an oscillator which defines how many megahertz or how many kilohertz will that processor be. On your left side, you see a microcontroller which is connected with a Bluetooth module. We will discuss them, how it works and how the functions are performed. But this is an inside of your basic IoT system. Now the question is, the CS guys will ask, what is it for us if we have not studied electronics, or if we have not done all these hardware configuration, how we can use an IoT? Because IoT is for everyone. It is not, the system is very simple. It is not hardware centric. It is very generic. So anyone can use it and use it to get their data. So the idea is that there are a lot of recent development boards which are targeted at IoTs, like the Arduino. It was a revolution. They just place the same things which are available over here. They just pick them up, connected in a board for anyone. Even small kids can use Arduino. Even non-technical people, people studying medical or people studying mathematics, anyone can use it. They don't have to deal with all these wirings and all these connections. They can just set up their system at home. If they have an idea to automate their home or to automate some process in their business, anyone can pick up an Arduino. We will discuss it in upcoming slides and just start working on these systems. So don't be afraid of these connections, because these are what is the basic principle of how an Arduino board or how a Raspberry Pi is designed. We will talk about them in the coming slides. Now Mr. Hussam will give you a brief idea of the same things, and then we will take some question and answers from this session. After this, we'll move to the next session, which is the basics of IoT.
بسم الله الرحمن الرحيم. راح أعطيكم ملخص كده سريع باللغة العربية عن الإمبيدد سيستم في حال إنه في عندنا طلاب من علوم الحاسب، يعني عشان تكون الأمور سهلة بالنسبة لنا. الإمبيدد سيستم أو نظام مدمج هو نظام مخصص مصمم خصيصا للقيام بمهمة واحدة. يكون أنت عندك هاردوير عندك عليه السوفت وير موجودين على الشيب، هذه الشيب مخصصة فقط للقيام بشيء واحد فقط. مع الأمثلة راح يتضح الفكرة بشكل أكثر. مثال، عندك الثلاجة في البيت فيها نظام قياس درجة الحرارة، هذا إمبيدد سيستم. أنت تعاير في الثلاجة لما تعاير القياس على رقم معين، السنسور الموجود في الثلاجة يحس بدرجة الحرارة، إذا نزلت عن رقم معين يرجع يشغل الكمبرسور، وإذا ارتفعت عن درجة معين يطفيه على حسب العيار اللي أنت حطيته. أيضا عندنا الإضاءة في الثلاجة، هذا برضو يعتبر إمبيدد سيستم. كمان شاشة العرض، في بعض الثلاجات الذكية فيها شاشة عرض تطلع لك درجة الحرارة وبعض معلومات أخرى، هذا برضو إمبيدد سيستم مختلف. أيضا في السيارة فيها أكثر من إمبيدد سيستم، مثل نظام قفل الأبواب، هذا إمبيدد سيستم لحاله. نظام الملاحة، نظام تثبيت السرعة. معظم الأجهزة الموجودة حولنا فيها إمبيدد سيستم مختلفة. حتى الجوال اللي عندك في الكاميرا إمبيدد سيستم، طريقة اتصال بالإنترنت إمبيدد سيستم لحالها. هتكلم عن البنية الأساسية للإمبيدد سيستم النظام المدمج. تلاحظ معي أن اليسار الإمبيدد سيستم يتكون من سنسور وأنالوج ديجيتال كونفرتر، بروسيسور مع الميموري اللي هم المايكرو كنترولر تكلم عنهم من السوشيال، وبعدين ديجيتال تو انالوج كونفرتر، وفي النهاية اكتويتر اللي هو راح يعطيك المخرج تبع السيستم اللي انت بنيته. عشان يتضح هذا البنية الأساسية تتضح تمام، راح نطبق مثال عليها، مثال عملي عشان يتضح الأمر. عندك انت مفتاح السيارة، نظام القفل، نظام قفل فتح المفاتيح في السيارة. لما تضغط بالريموت انت على المفتاح، تضغط بالريموت، الريموت بيرسل سيجنال، بيرسل إشارة يستقبلها السنسور الموجود في السيارة عندك. هذا السنسور يستقبل هذه الإشارة وتكون أنالوج، يحول لك هي إلى ديجيتال عشان يفهمها المايكرو كنترولر، والمايكرو كنترولر ياخذ هذه السيجناليزات ويعالجها ويفهم إنه مطلوب مثلا فتح قفل الباب، ويعطي أمر يخرج على الديجيتال تو انالوج كونفرتر، هذا راح يحولها من ديجيتال لانالوج مرة ثانية وتطلع على شكل إشارة كهربائية تترسل للأكتويتر اللي هو فالي الحالة، يكون السويتش أو الجير أو السيرفو هو اللي مسؤول عن فتح أو قفل الباب. فالمكونات الأساسية لو تلاحظوا للإمبيدد سيستم، أول شيء سنسور ومايكرو كنترولر وأكتويتر. سنسور عشان يجمع الداتا، مايكرو كنترولر حتى أنت تكون مبرمجه عشان يعطيك النتائج اللي تبغاها، والأكتويتر هو اللي يقوم بتنفيذ الأوتبوت ويعطيك النتائج اللي أنت طالبها حسب السيستم تبعك. كذا نكون انتهينا من الجزء الأول من المحاضرة. إذا في أي أسئلة أو استفسارات قبل ما نبدأ في الجزء الثاني. Okay, anyone questions? Okay, so let's move ahead. So what is an IoT? As we discussed a bit in the concept of the starting slides, an Internet of Things is a combination of or a network of things which are
being given some unique identities like IP addresses, so they can communicate with each other instead of just communicating with us. They can communicate and perform some operations or give some information to the other things. The focus is on the configuration and control and the networking of embedded systems. Previously, when I was graduating, these things were called network embedded systems. Like you have an embedded system, if you network it, or if you put it, give it some Ethernet connectivity or some Wi-Fi connectivity, those things were called network embedded system. An Internet of Things is a new term for the same technology. You have a specific device which is connected to an embedded system, and if you provide some internet connectivity, some Bluetooth connectivity, that becomes a node in the Internet of Things network, and it can communicate. For example, your water pump is a dumb device. It is not connected to the grid. You can connect it to your water pump to a network, and then it will be automatically, you can schedule its turning on and off, or you can connect it with another thing which is maybe in your underwater tank or in your groundwater tank sensor. So it can tell the system that okay, now the water at the top of the tank is empty, you can turn on the water pump and move and stuff like that. Utility meters, you would have seen these days, the Saudi Electric Company is replacing the old meters with the new Wi-Fi based meters or the network connected meters. What is the advantage of this system? The advantage is that now you don't need meter readers or people going to every home to read the utility data of your water usage, of your electricity usage, or any other thing. Network connected utility meter will automatically measure all these things and just send it to the cloud without the need for having people involved in all these levels. Car engine, we have now electronic cars coming which will be auto driving. Of course, if we need an auto driving car, it has to be connected with the server so it can get real-time information of all the accidents, roadblocks, and new blockages or any other thing. Similarly, about the air conditioner and the printer, you have already used them. We have a lot of Wi-Fi printers. You just print it from from one room, and the printer is in another room, but they are all connected to the cloud. That is an Internet of Things. The printer can get information from some other connected thing. Air conditioners, we have a lot of Wi-Fi air conditioners where you can use your phone to control it, to schedule on and off and all these things. But the only thing is not to connect it to the internet. The main purpose of the Internet of Things is because that thing is called a smart thing. Whatever has a Wi-Fi or a Bluetooth, you call it a smart. Like you have a phone, if it has connectivity to the grid and all these things, you call it a smartphone. Similarly, you have a thermometer, it is a normal one. If you connect Wi-Fi, if it can record your data and send it to the server, it becomes a smart thermometer. So that is not the only purpose. The purpose for the IoT based revolution is to make the systems talk to each other, which is we call it M2M or machine to machine interactions, and that will be based on artificial intelligence algorithms, because a machine cannot decide for it like what it should do, or what is, if the input is like this, what should I do now, what should I do now. So that everything will be based on artificial intelligence algorithms. The purpose of IoT will be to provide those algorithms some input, because for everything, like us humans, our brain works on sensors. If we don't have eyes, if we don't have the touch senses or the smell or anything, we cannot, brain will not process anything. For brain to work, it needs ears and eyes and hands and all these things to observe and give it some input. Based on that, it will perform its decision. So similarly, to have a global connectivity, you need some sensors which will calculate all these things, send the data to the system, and then perform. Sorry, someone was asking some question. Can you repeat it? So okay, if anyone has a question, he can write it in the chat. Sorry, I saw something and then it disappeared. So the basic purpose of the IoT system or the Internet of Things is to communicate between the things which are there, which are smart now, which have Wi-Fi connectivity, but they are not interacting with each other. They are all interacting with you only. For example, we will talk about these things in the last slide as well. What is in the future for IoT? I will just give you a small example. For example, you have a smart band or your Apple Watch or your Galaxy Watch. It is a smart band. It will detect your heart rate and heartbeat and everything. Then it will upload the data into your smartphone. But for that you need an app. Similarly, you will have some other smart scale maybe for the weight. You will detect that, and then there is another app. For your air conditioner, you have another app. Then for your electronic lighting, you have another app. Everything is controlled from the apps, but those apps cannot interact with each other. They give you the feedback and you give them the feedback, that's it. They cannot talk to each other. Your smart band cannot talk to the weighing scale, or your smart band cannot control the air conditioner in your room if the temperature is high or low. So the purpose of Internet of Things is to make an internet which is only for the things, so they can communicate with each other based on some set rules or the algorithms. Some basic history of sensing and Internet of Things we had around in the late 90s. We had RFID. You would have seen RFID. These days it's the cheapest technology for identification. You would have seen them in Center Point, in the clothes shop and everything. Whenever you buy, you remove its RFID tag from that product. It is just a cheap, maybe comes in 8 halala or 10 halala tag. You just put it on your equipment and it is detected. But it is a dumb thing. It is only used for communication, to send the data on the identification part. Then in the early 2000, we got some information. In the early 2000, we got some equipment which were communicating based on their sensors. We called them wireless sensor and actuator networks, or simple wireless sensor network. Those were some connected devices in a network or without a network, point-to-point or multi-point links. They were sensing some data from remote locations or here and there in buildings and all these things. And it was then that data was being relayed to the system from these devices. So these were industrial devices to monitor different processes in the industry and then relaying this data to a center point or a base station, and the base station would perform some operation based on that. But it was just an isolated thing. A sensor network can be deployed in a university. That sensor network has nothing to do with another sensor network which is maybe in some military organization or some hospital. Every sensor network was an isolated stuff, sensors connected, giving you a data, and based on that data, like fire alarm system and maybe some oil refinery. So those sensors will detect all the data for fire. If there is a fire, it will ask the central control system to shut down that fire. But still, these things were not on the grid. There was no IP connectivity or anything. Then in the mid 2000s or 2008-9, we got some smartphones, PDAs, and all these things, which allowed us to interact on the internet remotely or in a mobile way without having to stay sitting in front of a PC or anything. In 2010 onwards, we got a lot of smart devices, which were not just like the phones or tablets we had. They were like smart temperature sensors, smart air conditioners, smart watches, smart goggles like the Google Glass, and smart cameras which will detect any motion and all these things. Then we started to have navigational systems which will detect the GPS in our phone and like Google Maps and give us the location and all these things. So this was the last 10 years. We got a lot of these things, the smartphones, smartwatches, and all these stuff. Now what is in the future? In the future is how these things which have already been, we have converted them from being dumb to being smart. They are all smart. Now how can they communicate with each other? How we can create an internet for them so they can perform some operations or talk to each other, and based on that give us some data. The server calculates some, and based on that perform some operations and ask the actuator to do this, do that, and stuff like that. So this is the basic idea or the general history of how these systems work. With the increasing number of connected devices, you would have, maybe if you, some of you studied networks, you know, IPv4 had very limited addresses, so now we have IPv6, in which we have a lot of different IP addresses available, because the number of devices are very drastically increasing. So if we have a lot of devices, we need a lot of IP addresses for all of these devices. Similarly, with the advent of 5G, once we have 5G everywhere, all these devices will be very easy to connect. 5G technology has a side technology which we call the NB-IoT or the narrowband IoT. These days, the STC, ZAN, Mobile, everyone has started that technology. So that communication system, it is just like a SIM, but it is a SIM for the device. It is a SIM for your maybe a smart card reader, which you go at the shop and you are swiping your card there. So that device is remotely connected to your bank server. When you swipe your card, it will take out the money from that thing. But the SIM and the stuff it uses is not the general purpose SIMs that we use. NB-IoT is a specific technology which is only for the thing. So with 5G, we will have a lot of different communication protocols. The main purpose is how to talk to the grid, how a chair can talk to the cloud, or because the cloud is just a server or a computer and someone has programmed it or developed some algorithms on that. But the main thing is how do we send the data from my chair or the pressure data or the movement data or all these things to the cloud. So for that we need different connectivity methods. If the chair is in a house, we can use Wi-Fi. If it is close to a phone, we can use Bluetooth and stuff like that. We will discuss in the coming slide. This is the basic anatomy of a thing. What is a smart thing? A smart thing, we discussed it multiple times. It is just a device with an embedded system or a microcontroller. It will have, like, this is a bulb which has some motion sensor. So we have one sensor which will detect the motion. There are some bulbs or the LEDs which will turn on when there is a motion, and the microprocessor will receive the data from the sensor, which is the motion sensor. So anyone, when he enters the room, the motion sensor will send a 1 to the microcontroller. The microcontroller will send a 1 to the lights and they will turn on. Similarly, when he leaves the room, the sensor will send a 0 to the microcontroller will send a 0 to the LEDs, and it will be off. So, and in doing so, this microcontroller should also be connected with Wi-Fi. It should have some Bluetooth or some, so far it is not an IoT node, it is just a thing. It has no Internet of Things node capacity. So once we connect it with Wi-Fi, then we can, a fan can communicate with it, or my air conditioner can communicate with it, or my phone can communicate with it to schedule its on and off. If I don't want to be turned on with motion, maybe I want it on all the time. So I should have an override function from my phone which can turn it on anytime I want. So once it gets the connectivity, it becomes an IoT node, a node in a large network which we call an Internet of Things. This is a basic architecture of the node device for a complete network. We have the perception layer where we have the sensors, very limited work because the sensor technology has also always like it has matured a lot. We have ready-made nodes, we have ready-made sensors. We don't need to connect all these things by hand. Everything is available these days. We can buy a ready-made system. The main thing lies in the application layer and in the network layer on how to use these smart devices to communicate and to connect with it. Although our today's lecture is just an introduction, it is more focused on the perception layer. We are hoping to have another talk sometime in which we will talk about the application layer in detail. What are the cloud services available like Amazon IoT Cloud or Google IoT Cloud, and how can we use them? Today we'll talk about ThinkSpeak, which is another server, but most of the recent stuff is being done on Amazon Cloud or Google Cloud for the IoT. They have the specific APIs for IoTs. So, but today we are focusing more on the network and the perception layer. because it is the start. We always start from the down, from the bottom up. So we will start about what are the sensors, how they can be connected, if we want them in our home, how can we use them. Later on we'll move on to network layer, and then what are the cloud options and how we can use the data which we have. By the way, for the CS students, the application layer will be very easy. It is just like you have an Excel file, you have a lot of data in that Excel file for maybe temperature or for student marks or anything, and then you use your analytics or your analysis software. So it is the same thing. Only thing different is that this data is now physical and it is coming from some car or from some person. So it is not a random data, or it is not text data. It is mostly numbers and digits, and the data is for either his weight or his jogging or his motion or his car and all these things. So we have the hardware, which is the main thing. Then we connect it with the sensors, we connect it with the communication technology, and this embedded system or this hardware becomes an IoT node. Then we talk about the protocols for IoT. There are a lot of different technologies on how we can send this data to the server, what software IDs are used on the perception layer, and what are the cloud platforms, mostly Google Cloud and Amazon AWS, but their cloud API is not the generic servers, the cloud specific, the IoT specific servers. So Mr. Hussam will give you just a brief explanation of this health monitoring scenario. Consider it's an old person who is being given some sensors by the hospital, and he is moving and sending the data to the cloud. So Mr. Hussam will explain this slide and the next one, and then I will take over.
عندنا الآن سيناريو على هيلث مونيتورنج سيستم. أمامك هذا الشخص، يعني شخص يمكن يكون كبير في السن أو مو شرط يكون كبير في السن، يمكن شخص رياضي، لأنه هذا السيستم مستخدم بكثرة عند الرياضيين، يتابع صحتهم. وتلاحظ على يده ورجوله في سنسورز، وفي سنسورز تقوم يعني تقيس الموشن، تقيس حركته، وتقيس تسارع نبضات قلبه. وجميع هذه السنسورز بترسل داتا، بيانات عندك على الجوال تبعه. هذه البيانات كلها تخزن على النت على السيرفرات، بحيث انها تتم معالجتها، يتم مقارنتها بالبيانات والداتا اللي تم تسجيلها في ايام مختلفه او اسابيع مختلفه، ومنها تحصل على تقرير كامل عن ادائه هذا الرياضي، او عن إذا في مشكلة في يوم من الأيام في تسارع ضربات قلبه، إذا في إحتاج مشكلة في النظام الغذائي. هذا المثال لو نطبق على نفس هذا الرياضي اللي عنده لابس ساعة، مثلا ساعة ذكية. هذه الساعة الذكية مكوناتها تكون سنسور عشان تكولكت الداتا، فيها أيضا بروسيسور. البروسيسور هذه تكون البروسيسور يقوم بمعالجة الداتا هذه، بعدين يرسلها على الكوميونيكيشن موديول. الكوميونيكيشن موديول هي تقوم بإرسال هذه الداتا للإنترنت. طبعا هذه الساعة تحتاج لباور سبلاي، اللي هي في هذه الحالة تكون بطارية. والداتا اللي مرسلة عبر الإنترنت تستقبل عندك هناك السيرفرات. السيرفرات هذه بتخزن الداتا وتعمل تحليل، وبعدين تعرضها مرة ثانية سواء على شاشة كمبيوتر أو شاشة الجوال عندك، عشان لدراسة هذه الداتا ومراقبة، زي ما قلت، مراقبة أداء الرياضي. هنا عندنا بعض البلاتفورمز المستخدمة، مشهورة مستخدمة في الإنترنت اوف ثينجز. تلاحظوا أن أشهر اثنين أو أشهر بلاتفورمز مستخدمة في الأردوينو والراسبيري باي. والأردوينو فيه أكثر من نوع، عنده أردوينو ميجا، أردوينو أونو، أردوينو نانو، الراسبيري باي 2 3 4، في راسبيري باي 0. كل ما عليك انك لما يكون عندك هذا الأردوينو فقط تشبك فيه السنسورز، وراح يجمع لك الداتا يعالجها في المايكرو كنترولر الموجود داخله، ويعطيك الاوتبوت حسب الاكتويتر اللي انت شابكه على الاردوينو، حسب السيستم اللي يكون عندك. هذه مجموعة من البلاتفورمز المستخدمة، اردوينو وراسبيري باي، زي ما انتم شايفين احجامها مختلفة حسب السيستم اللي يكون عندك، وحسب السيستم انت فين تبغى تضعه عشان ياخذ قراءات ويعطيك مخرجات تختلف بالاحجام. هذا الاردوينو ميزة الاردوينو هذه انه يجي معاها تول البرمجة، تبرمج انت الكود اللي تبغاه بنفسك، مكتوب بلغة سي بلس بلس، وترسله على الشيب وهو يقوم بتنفيذها. هذه بعض الأوامر اللي موجودة في التولز، أوامر بسيطة. إذا أنت درست بداية طلاب علم الحاسب درس سي بلس بلس يكون عندك خلفية عن هذا الموضوع، تزيد رايت قراءة وكتابة الداتا. راح نتكلم بشكل مفصل عن السنسور. شو السنسور اللي يستخدم عندنا في الانترنت، في الانترنت اوف ثينجز او انترنت الاشياء؟ السنسور هو عباره عن ديفايس، جهاز يلتقط فيزيكال كوانتيتيز، يلتقط يعني اشارات فيزيائيه، مثلا صوت او حركه او لون او اي شيء، وتحول موجه كهربائيه وترسل له على الاردوينو تبعك او على المايكرو كنترولر تبعك. وتيجي السنسورات بأنواع كثيرة ومختلفة زي ما انتم شايفين هنا الانترنت. في بعضها يكون ميكانيكال، مثلا قياس الحركة، الأكسلروميتر قياس التسارع، الجيروسكوب عشان قياس عندك التوازن. في بعضها يكون اوبتيكال، قياس شدة، مثلا الفوتو ديتكتور قياس شدة الضوء، الانفراريد زي اللي موجود عندك في ريموتات التلفزيون، يكون مرسل لمستقبل انفراريد. في بعض السنسورز تكون سيمي كوندكتور، يعني مستخدمة لقياس درجات الحرارة، الدخان، في هذه اللي نظام أنظمة إطفاء الحرائق فيها سنسور، لما يحس بالدخان على طول يعطي أمر لرشاشات الموية تنزل الماء. هذا أحد السنسورات، كلر سنسور، يستخدم في معرفة الألوان. إذا جيت عندك اشتغلت شوية على الألوان تعرف ار جي، ار بي جي، ريد، بلو، جرين، كل واحدة لها قيمة معينة، هو يسجل هذه القيم الثلاثة يجمعها من بعض ويطلع عندك اللون. هذه الناس اللي شوية اشتغلت في ايمج بروسيسنج تعرف هذا الموضوع. أيضا نوع آخر من السنسورات، سنسورات تقيس الجاسز أو السموك زي ما أنتم شايفين. بعضها تقيس السموك والكحول أو الأكسجين، ثاني أكسيد الكربون، الهيدروجين في الجو. طبعا زي ما انتم ملاحظين إنه في حساسات سنسورز مختلفة كثيرة حسب السيستم أو النظام اللي عندك. يعني أنت بس عندك تتخيل إيش ممكن تبى تسوي بهذا السنسور الموجود. هذا الجي بي اس زي ما أغلبكم يعرفوا، يتلقى إشارات من الستلايت عشان يعرض اللوكيشن اللي أنت فيه عليه. هذا السنسور باور مانجمنت يكون بقياس التيار الموجود عندك في الدائرة، يعطيك كم الأمبير اللي موجود عندك في الدائرة. الليدر سنسور، السنسور هذا يقيس المسافة بين الأشياء، ويمكن يقيس تقريبا 12 متر، وبيستخدم في قياس زي ما شايفين في الصورة عندكم البعد عن السيارة. هذا السنسور التراسونيك سنسور برضه يستخدم قياس المسافات. هذا أصغر شوية من اللي قبله، وفقط ل4 متر تقريبا. وهذا تلاقيه موجود عندكم في السيارات، هذه حساسات السيارات اللي تقرب من السيارة وتطلع لك صوت تقدر إذا في سيارة على يمينك أو على يسارك. هذا أيضا نوع من السنسور، بعضكم يعرفها وبعضكم لا، بس أكيد الكثير منكم استخدمها. RFID زي اللي تكلم لكم على محسن، تحصلها في سنتر بوينت. سنتر بوينت لما تروح تشتري ملابس في تلاقي زي القطعة السوداء موجودة في اللبس. أحيانا إذا المحاسب نسي يشيلها من عندك أنت خارج، في عند الأبواب ديتكشن يطلع لك صوت على طول. هذه البصة السوداء هي RFID سنسور بسيط جدا، مجرد تاج، يعتبر تاج للأشياء. بينما ال NFC زي ما انتم عارفين موجود في الجوالات وعلى البطاقات الصراف، تتواصل مع الأجهزة وممكن من خلالها تدفع فواتير، تدفع فواتيرك. وأيضا كمان يستخدم في الأبواب الأكسس، security access من بعض الأبواب برضه من طريق ال NFC. فرق يفرق عن ال RFID إنه ال NFC هذه تشيب موجودة سواء على الجوال أو على بطاقتك، ترسل وتستقبل داتا وممكن يدخل فيها التشفير أيضا. لكن ال RFID بسيط جدا ومجرد الاستقبال. في عندنا هنا الأردوينو بورد، هذا برضه مجموعة من الحساسات موجودة مع بعض. temperature pressure humidity، إذا كان طبعا السيستم تبعك اللي تبغى تصنعه كبيرة ويحتاج يعني أكثر من سيستم مع بعض، والأردوينو جمعوها مع بعض وضعوها في الكيت. وكذا يكون انتهينا من السنسورز. راح ندخل الآن. هذا السنسور طبعا يعتبر الانبوت تبع السيستم تبعك، هذه اللي كولكت داتا بعدين ارسالها للاردوينو او المايكرو كنترولر لمعالجتها. بالنسبه للاوتبوت موجوده هذه الاكشويتر، هي اللي راح تقوم بعد المعالج، بعد المايكرو كنترولر بعد ما يعالج الداتا راح يرسلها على الاكشويتر. راح نتكلم عن الاكشويتر هذه بالتفاصيل مع مهندس محسن.
So you saw some of the sensors which we use in the IoT devices, not just IoT devices, in any electronic system we need some sensors. These fire alarms and safety systems are already there, just that they are not connected with the Wi-Fi, so we call them just a normal embedded system. These sensor technologies, all of them which you saw, like a push button or a touch button or a gas sensor, they are already there around you in your homes. You have in every lab, for example, we have a fire sensor. So that fire sensor has a methane and a smoke sensor and everything. It's already there. So we don't need to redesign all these things from the scratch. But even if we want to use them using an Arduino or a Raspberry Pi, the first thing is we choose the board or the platform which is the smallest of available options, which is according to our needs. We don't need a high power requirements system unless we don't have a high power requirement application, because we are always limited on power in case of these things, because not everything is connected to the electricity grid. Most of them are mobile devices. So once we choose the platform from Arduino or Raspberry Pi is like, for example, a quad core system. It is a 64-bit quad core processor, so you don't want to use it for a thermometer or a remote control. You will use it obviously when you are taking input data from a camera or counting cars or counting crowd using an image processing algorithm or any advanced AI system. So when you are using that type of processing on spot, and then you use a powerful processor. If you just want to use it for a sensor, you use a normal processor or a low cost microcontroller. In case of actuators, once we have the input, we want to perform some operation. What can those operations be? They can be a 3D printer. A 3D printer will print. You have sensed. We have the blue color thing in the screen is a relay. A relay is just like an electronic switch. When you give it 5 volt, it will turn on the bulb or a fan or anything, and if you give it a 0 volt, it will turn it off. We have some motors to move things left or right. You can see the door lever which can open or close the door based on, maybe you can tag scan your RFID, it will open the door for you. If you scan again, if it is wrong, it will close it or something. We have a servo motor which can we normally use in robotics to change directions, move left or right, and you can see a water valve as well, which can electronically control the flow of water, like we have them in the petrol pumps. When you program it that okay, I need 50 reals, so it will turn it on, the petrol will run for that much time, and it will automatically shut out the petrol after the fixed amount has been transferred. So these are electronic switches, all of them. Of course, we are working on an embedded system, so things will be electronic, but they come in different form and shapes. I will start with two or three of them, and then we'll move on to the server side. The actuators, the common ones are a stepper motor. A stepper motor is a motor which you find in your printers, in your 3D printers. It is just a normal motor. The speed is very low, but the accuracy is very high. You can exactly tell it, like in your robotic arms, you want the arm to move to a fixed point in a very specific way. It should not go left or right from more than which it is programmed. Similarly, in the picture below, you see a 3D printer. In a 3D printer, a system is moving left or right to control the flow of the liquid which is printing the item at the bottom. So you don't want it to go out like due to some irregularity or inconsistency. We want very accurate control. So whenever you need a slow speed motor with accurate control, high torque means if we need more power. In these cases, we use a stepper motor. It has a stepper motor driver. For example, you see the green color in the middle of the picture, and then we have a microcontroller or any ready-made platform that you pick and program it. Just connect the two wires and it starts working. For practice, we can have like a stepper motor. You just connect 2 or 3 wires with the Raspberry Pi or with Arduino and just program it. The core of this whole idea is programming. If someone is good at programming, the hardware details are very easy or abstract. Everything is very simple. You just need 2 or 3 wires to connect them. Mostly in high schools the kids do it, so it's not very tough. The basic thing is how you program it and what is the application that you want it for. We have a DC motor. A DC motor is high speed, but it is not very accurate. But for applications like a propeller for a drone, or a fan for a drone to lift it up or lift it down, or something in which you require high speed, we use a DC motor. DC motor is the same like a stepper motor, but it is very fast and it is not very accurate. You cannot move it 1 degree or 2 degrees. Once you give it power, it will move maybe 1 or 2 times and then it will stop. You cannot control the flow exactly. In stepper motor, you can just ask it to move only 2 degree, 5 degree, 10 degree. It will have a very accurate control. So in some application we can use a DC motor. A servo, mostly used to turn on and off stuff or to move things left and right. Normally in the drones we use them in the wings to move them up and down. A servo does not rotate 360 degree, it will rotate only 180 degrees, so it can move from the left to the right and then from the right to the left. So these are the only 2 options which we have. We can use them to, for example, if we want a hardware solution to press the button on a lift without touching it, a servo can be connected there, which can turn on a button, press a button, and it will turn on like take you to one floor. Then you can give it another input, and it will move. Press another button. So usually servos are used where we have a limited movement. For example, 180 degree, not more than 180 degree movement. In that cases, we use servo motors. But these are all family of a single motor, like a DC motor, stepper motor, servo. They are all the same basically, and it depends on how powerful you want. For example, the image at the bottom, it is a very high powerful power servo, usually used in your car and to turn on and off the wipers and your windscreen cleaning stuff. So in such cases, or if you want to lock a door and unlock a door, we use a high power servo. Otherwise, we use the small one. The most important thing, if you are a computer scientist or a computer engineer, the most important thing you should know is an actuator. An actuator is an electronic switch which is used to turn on and off high voltage devices like a fan, or we are not talking about digital 0 to 5 volt or 10 volt stuff. We are talking about 220 volt and like a monitor or a screen or a projector or your lights. So these are the major things, because in smart home these play an very important role, because we have to connect all the appliances to the power and based on that we can do cut the power or turn on the power, turn on the lights. If someone has entered the room, we say, okay, this guy has entered, let's turn on the light. If he has left, let's turn off the light. Also in case of an alarm system, like if you have a fire, what should be done. If you have an automatic sprinkler system, the relay will automatically turn it on, and all these things. So what is a relay? A relay looks something like this in the blue color. On one side you have the inputs from the device, the 220 volt device or the 110 volt device, which can be your microwave oven, it can be your light, it can be your fan, anything. On the other side is a ground and 5 volt, which is a fixed supply. You connect it to a battery, and then there is a signal pin. The signal pin is just, if you give it 5 volt, it will turn on your bulb. If you give it 0, it will turn off your bulb. So it is just like a switch that you use in your labs to turn on and off the light, or in your homes. But this one is an electronic one, and once this switch is connected to a Wi-Fi device, like you can see at the bottom, then you can use your mobile phone to on and off these things. These smart devices are already quite common, they are already around you, but the basic concept is how to deal with this thing with like with the internet, so another device can turn it on or off this thing. So we have a relay which is connected to a web server, and we are using a Wi-Fi module from the web server to the mobile phone will ask my gateway or my router to send the data to this Wi-Fi device. It will ask the relay. You can see we have at the bottom we have 6 or 7 relays. So when you are automating your homes, when you talk about smart homes, of course you have 100 or 200 equipments like lights or fans and all these things in a big home. So you need a lot of relays and a microprocessor with a lot of pins, so you can connect each one of them and you can control them from your server, or your artificial intelligence server can automatically control all these things if someone is coming or someone is leaving. This is how a relay works. You have a lamp, one side is connected, the other side is broken. The red wire, you can see it is broken using a relay. So when you give a 1 from the Arduino to the relay, it will be on. If you give it a 0, it will be off. This is a very simple thing, but what you don't study, we usually don't study them in our courses or anything, but we should know about it, that how a relay can be used to communicate, or how a relay communicates with the devices, and how we can turn on high voltage, high power devices using this equipment. Then a small demo. Hussam told you about some of the sensors. This is simple case study of a sensor or an IoT node. You can see the white color, the DH22. This is a humidity sensor. You saw it over here as well in the list of the sensor which we had. This is the temperature and humidity sensor. It's not a digital sensor. There is a difference between analog and digital sensor. If you have an analog sensor, it will give you a voltage for some value. If you have high temperature, right over here, you can see we have some temperature values from -40 degree to 55 degree. For every change in every 5 degree or 4 degree, you will get some voltage on the output pin of that sensor. That is the only thing we will get. We will not get a digital value. It will not tell us, okay, this is 35 degrees or the temperature is 5 degrees or -5 degrees. It will give us a voltage value because it is an analog sensor, and then the Arduino or the microcontroller connected in Arduino, it has a built-in analog to digital converter. So we will connect. You can see there is a orange wire connected at the digital analog to digital converter pin. It is connected. It will automatically read that voltage, and a program will convert it into. That program should be written by you or from a library. It will automatically convert this signal into a temperature value, and from there you can connect using this ESP8266 IC, send this data using the blue and the green and the yellow wires to this device, and this device will connect to your router or your server, and it will automatically send this data to to your server. From the server, the thing you see on your left, this is called a dashboard. Once you have the data in the server, the computer scientist will know. Once you have a table, you can easily plot curves. You can auto update this curve every 2 or 3 minutes, and you will see all these the data coming from the sensor. You can create like a graphical interface for it as well. We are talking about things board, which will give us all the data and all these visualization tools automatically. We just need to tell them we have an Arduino and this sensor, but it is not customizable. Of course, you cannot sell it, you cannot use it in your devices. You can for educational purposes, it is fine. When we move to permanent solutions, we ought to have like Google Cloud or an Amazon Cloud, our own dashboard system like this that we can sell to the customer, or which the customer can use in his applications as well. But for learning purposes, ThingsBoard or ThingsSpeak is the best. You can get all the data uploaded onto the server, and there you can plot it. You can perform data analysis. We are wishing to have like some groups from the computer science in the future once the next semester starts, which will work on the server side of the Internet of Things stuff, and when we can have 2 or 3 groups from the computer engineering side who can work on the data collection side, and then we will merge the total solution. We have some ideas in mind, which we will maybe in our next workshop or seminar we will propose them to the students so we can have them on board. So this is a complete system. You would not know about what is ESP8266 because I will go forward and explain it in the communication technologies. But this is how our complete system works, and it is not some rocket science. Very easy, even for a non-electronics guy who has not studied electronics. You just go to the internet, find out which wire and which pin I have to connect where, and it's just 3 or 4 wires, and that's it. So, and it will start giving you data, and it will start uploading the data. You just give the server IP and server connection, and it will start working. Okay. So I explained this slide a little in the previous stuff as well. This is the temperature data which we have. This is the voltage levels. The microprocessor, the output will be something like this, which we see at the bottom. So this is the job of the microcontroller to convert this analog data into digital. You can see the bins. So this is a binning technique or a PCM. We have these green places. We convert this data from analog, which you can see the analog black curve. We convert it into digital values, fixed point. Of course, there will be some loss of accuracy, but now we will have some 8-bit or 12-bit digital data, and that data we can every temperature sensor company will give you a formula that once you have an 8-bit analog data from this sensor, multiply by this, divide by this, and you will get a temperature in your centigrades or humidity in relative humidity units. And so you can see on the right side, this is the Amazon server. The data is there on the Amazon cloud. You can see the device ID. The device number 3 is sending humidity and temperature. Then the device number 1 is sending the data, and then the device number 3 and device number 2. So you have node IDs to identify which device is where, and then you have the data for the sensor, the humidity, temperature, and the light data. Maybe there is a light sensor as well in the system, which will give you. So these 3 data is coming from these 3 sensors and from different nodes, and then what we can do is based on these columns we can perform some data analysis, predictive analysis, and simple sort of stuff. And based on this data we can control some other equipment which is connected with the actuator. So any IoT node which is connected with an actuator, with a fan, with a lever, or some electronic control relay maybe. So based on this data we can perform our future operations. But this is how a complete sensing system looks like. We move on to the communication technologies. When you are working on creating a node, an IoT node, the basic thing, the important thing is to consider the data rate of your application. For example, if you are using a camera, or if you want to count cars on the road using a camera sensor, of course your data rate will be very, very high. You will be getting 30 to 60 frames in 1 second, and that will be like in MBs per second. So you need a very, very strong link, and that is not a job of a low data rate technology or a low power technology. Of course, you want a fixed connected grid over there. You should have electricity connected because it is a high data rate application, and you, of course, your microcontroller or microprocessor will be very heavy, and the communication technology will be like 4G LTE or like 5G or something like that. But if you want to just count the number of cars, that whenever a car goes, my counter will say 1. Whenever a car comes, my counter will say 2. So now I am counting the cars, I am not identifying the cars. So I can do this using any sensor, and this type of data is very less. You just have data in maybe bits or bytes. So for that data, you don't want to use like a 4G LTE system or a 5G system. You can do that using small technologies. We will talk about them. So the first thing is the data rate, then the technology, is it licensed in a licensed band or in a non-licensed band. Then we have how much will be the power consumption. If the data rate is high, if the processing is high, of course the consumption will be high. If you want a technique with low data rate, the power consumption will be less. Then do you want a point-to-point connection, like it will be deployed on the road and sending the data to your office PC only, or you want that device to send data to another device and that device sends data to another device and then it reaches you. So whether it should be a point-to-point network or a mesh network, or the number of connections, how many number of, for example, Bluetooth, it supports very little amount of mobiles which can communicate with your phone, maybe I don't know 10 or 15 or something like that, but not more than that. You in your Wi-Fi devices at home, usually they support 25 or 100 or 50 based on which router are you using. So very limited number of connectivity. You cannot have a single Wi-Fi device to connect with the thousands of devices. So this is an important consideration of what will be the number of devices around this device in which you can in which this can communicate. The architecture or the protocols, the network architecture and the protocols are very simple in IoT, and they are not very power consuming. The main reason is that things are mobile. So because they are mobile, we need to save power. Okay. And in the short range technologies, we talk about Bluetooth, Wi-Fi, and Zigbee. Bluetooth, you have all used it. It will work only in a single room if you are communicating from one device to the other. Wi-Fi, it can have a coverage on the range of a home or a small organization. We can connect different Wi-Fi devices to make a large network like we have in the universities or in an organization. Zigbee is a very short range, like 100 meters to 200 meter technology. Wi-Fi and Bluetooth are still very, like, data rate is high. Zigbee is only 100 and 120 kilobytes. So if you have a remote control or something using which you want to control it wirelessly, we use Zigbee controllers. They are like if you want to control your maybe your projector in your room or something else. So for such applications we use Zigbee. The advantage of Zigbee is it can connect a mesh network, it can create a mesh network, and it can send its data to another node. That node sends data to another node and ultimately to the base station. Bluetooth is medium range, medium data rate. Zigbee is high range or longer range relatively in the short range version. And the data rate is low. Wi-Fi has medium range, not very short, but the data rate is very high. You are using Wi-Fi for your Facebook or Twitter or everything, and there is no issue with even if you are using YouTube at very high data rates. In the long range ones, we have LoRa, which is high range but very low data rate. Then we have the narrowband IoT, which is a new technology these days. All the telecommunication services, as I told you, are using it. This is a licensed band version. We remember we discussed that we need to see which technology is free, which technology is in the licensed band. Bluetooth, Wi-Fi, Zigbee, they all work in the free band. LoRa also works in the free band. The NB-IoT does not work in the free band. You need to buy the SIM from some company who is already having a license, like Zan or STC. They will give you an NB-IoT or a narrowband IoT SIM, and then you can use it. Similarly, for 5G, you can just not create a 5G transmission, or you need a SIM, and you need to be connected to some server, which is the base station or the tower. So for that, you also need a SIM. LTE-M is also a licensed technology, and then we have weightless, which is recently gaining attraction. These are some of the technologies on your right, which are quite common. And they are based on the range, data rate, and all these things. So this is a graph on range versus power consumption. When you start your application or when you start building your IoT solution, the first thing that you have to keep in mind is what will be the data rate of my system, or expected data rate, or the maximum data rate, and what is the range in which I want it to operate. So Wi-Fi has a high data rate. The range is around 20 to 30 meters. Bluetooth has 1 megabit data rate, not as fast as Wi-Fi, but it is low power. Then we have BLE, ZigBee, and Z-Wave. We have RFID, which is very short. You can detect using an RFID car from maybe 2 meters, 3 meters, 4 meters, but not in a very long range. You have seen them in Center Point and all these shops. When you pass through the door, maybe even if you are a meter away, it will detect the RFID tag and it will start the alarm if you have not paid for it or something. Then the cellular, 5G, 4G, 3G, they are very high data rate. The range is very high because as long as you are in the range of the tower, you are covered. But you know that 4G and 5G in your phone, if it is on, if you are on data, the mobile battery is draining very fast. So you have to make a trade-off between which technology to use and how much battery do you have. Like if you have a smartwatch and you put a 4G SIM in it, maybe it will have very high data rate, but the battery is very small in a smartwatch, so it will drain out very fast. So why do we need like high data rate system for a watch which is just detecting my heartbeat and my basic systems? I'm not watching some high definition stuff on that. So why do we need a high data rate system? In that case, we will use either a Bluetooth or a Wi-Fi system instead of that thing. So again, it depends on your requirements. These are some of the technologies based on their range and power consumption and data rate. Of course, if the data rate is high, the power consumption will always be high. And also, if the range is high, the power consumption will be high. These are the ones which we recently imported. They can turn any dumb device into a smart device. This is a Wi-Fi module. Very simple. You just provide your server IP, which is your cloud server or your testing server or your root server, wherever you have made a server PC. You just connect with it and it will start sending it the data. You can store it in the database over there in MySQL or SQL or Access, anywhere, and then you can perform your analytics in the server later on. But very simple, very low power, and a lot of libraries and codes are available, easily implementable. These are the different versions. The module is on your right side, but there are different versions of it. You can have some of the pin outs. You can connect the pin to your Arduino, or you can just pick out the small connection, the small route device from the middle and connect it in your application. Depends on how you want to use it. Just a little information. This curly thing on every router, in every module is your antenna. It is just like a flat wire but twisted to fit on a small space. This is your, so whenever you have like those who don't know about the PCBs or the stuff, whenever you see a device, if it has some sort of a wire going up and down or random motion, that means it is the antenna and this is a transmission module. But if it's not there, it means that this device is not communicating. This is a Wi-Fi module. It has the Wi-Fi antenna connected to it. The original size is very small, as you can see in the middle, but the board is large. This board is just giving you access to its pins. Otherwise, we just pick it up and put it in the main motherboard without using all these boards. Here it is connected to a battery or a solar battery, and it will start working, sending you some data. It has a small microprocessor built-in available. You can program that as well if your application is very small. Otherwise, we prefer to use it with Arduino. We connect this with Arduino, like the temperature sensor application I told you, and Arduino sends it the data and it sends the data to the server, and it can also receive the data from the server, and maybe Arduino has some, for example, relay connected. Based on the input from the server, it can turn on that relay or turn off the relay. The code, this is all the code. Exactly like C, this is the Arduino API, which Mr. Hussam told you we are using in this PowerPoint presentation. We are focusing on the Arduino stuff only. So you just provide your username and password and your server IP, wherever it is hosted. If it is ThinkSpeak, it will just easily give you an IP and say, okay, connect it here and start sending your data. So very simple. We just have like, this is a UDP protocol we have implemented. So what we have is we just say UDP.read. It will read the data. If we have a like UDP.begin or UDP.write, it will just write the data whatever is received or it is sent. So this is not very difficult to set up. The libraries are easily available, and that is all the code which is needed only for the transmission part. Of course, when you are using Arduino for sensing part as well, you will need a short code to sense the temperature data and all these things, and then move it to this device. This is a Bluetooth device. You can see the antenna is here. The device is only in the green one. The blue color big board is only to take out the output. It has two versions. We have both of them, HC05 and 06. One of them can be a master or a slave, like a phone can connect to it, and it can be the master of that phone. The other one is only a slave. It is only used to connect to a phone or anything. So if you have a patient monitoring system, if there is a patient who cannot move and you want to detect his different type of signals from his body, heartbeat, or some other type of signals, in that case, Bluetooth is the ideal thing. But the only problem is he will have to have a Bluetooth phone nearby, which he can use to like connect with, and then this device will send the data to the phone. So in applications where a phone is available, we use Bluetooth because Bluetooth is low power, and the phone will be connected, or some Bluetooth device, a Bluetooth gateway will be connected to it, and it will be reading the data from that device onto the phone, and then the phone can be used to connect to the Wi-Fi network, from where the phone can send that data to my server or to the other applications or all the other devices. So in such cases we use Bluetooth, but if you are high on power, you don't have a power requirement, or you have a lot of power, you can use Wi-Fi, because if he is in a hospital, of course he will be under a Wi-Fi cloud. So if we have a Wi-Fi module, the device can receive his data, his body vital signs, and he can send the data to the server using a Wi-Fi connection. So Bluetooth and Wi-Fi are mostly the same. If you want direct IP connectivity, use Wi-Fi. If you want indirect IP connectivity, use Bluetooth. In case of indirect connectivity, first you have to send some data to an application on phone or on device like a phone, and then that device will send your data forward. But for easy application, Bluetooth is the best because it is low power and very easy to set up. We just connect the transmit and the receive pins with Arduino, and that's it. It will start working. You can send or receive. This is the Bluetooth code. We say we have two serial ports. The Bluetooth module works on a serial port. We have one serial port where the Arduino is connected with the PC. We say serial.begin 9600 baud rate. This is the Bluetooth module, the same. By the way, this code or that code, if you study embedded systems, you will only take 1 week to understand how to program Arduino or how to write the codes, what is a baud rate, and all these things. So very, very simple stuff if you know programming, of course. And then we say if eBlue is available, which is we defined it as a like at pin number 10 and 11 of the Arduino. So we can say, okay, now read the value, whatever is read, we just send it to the serial, or we just whatever we receive, maybe on the serial port, we just send it to the output and stuff like that. So in these two examples, basically what we are doing is we are receiving some data from the serial port of the computer, the user, or some application, maybe an Android application. It will send the data, and then we will receive that data and then write that data back to the terminal from where the data came. So it is like an echo test or stuff like that. But the basic idea is to show you that the code is not very complex. You just have the basic thing, the send and receive, and between that you can perform your operation. You receive the data, instead of sending it again, you do your operation, perform your operation, like inject this data into a database online. Also, you can perform some, you can check this data. What is this data? Is it above some threshold? If it is above some threshold, then write that data to the Bluetooth device. So if it is fire, if the temperature is more than 100 degrees centigrade, okay, just turn on the sprinkler or the fire extinguishing system, which is in place. Then we have the long range modules. These are used in applications which are wider. You can see in the pictures here. If you have an application where the data range is a problem, we use these devices. For example, if we want to detect the moisture of our crops in the field. Now the field is outside, there will be no Wi-Fi connection. If I use 4G LTE or 5G connection, it will take a lot of power, so I need a large battery to be able to operate it for 1 month or 2 months, because it will be over there and it will be operating. Otherwise, I will need a very large solar panel which can operate it. But in case of LoRa, we can have a small sensor which will detect the moisture of the system and send this data to another LoRa module which I can connect in my office, and I will receive. Maybe my office is 5 kilometers or 10 kilometers away from this thing. The range is normally 5 to 15 kilometers. So if I have an application, for example, in our office, in our building, we have a teacher car parking or instructor car parking, which is maybe 1 kilometer away or 500 meters away from the offices. Now, if I want to detect which slots are filled and which of them are empty, I can deploy some sensor to detect each car. If a car is there, it will send me a 1. If a car is not there, it will send me a 0. The data rate is very low, but there is no Wi-Fi, no connection over there. So what we can do is we can connect our sensor with a processor and a LoRa node, and it will receive that data and send that data to me in my office. And in my office, on the dashboard, I can see all the cars and everything, which car is not there, which car is not there. We can automatically mark people attended, like we can do their attendance, that okay, this instructor is here, this instructor is not here. Or if we want to know if this instructor is still in the office or not, we can check his car, or how much is this car occupying this space. The example is in your the new car parking system in Makkah, you have a person who is manually checking all the cars if they are occupied or they are not occupied. So he can lock them up if their payment has expired or stuff like that. So to automate this system, you will need stuff like this. You cannot work on Bluetooth or Wi-Fi because their range is very short. You need in every car or in every parking slot LoRa node which can detect the car with using a sensor, and then this node will send the data to the base station. It can work in mesh network, send the data from one to the other, and then to the base station. Or it can be a point-to-point connection in a system. So these are the 3 basic ones. If we talk about the 4G, 5G ones, we also have the similar modules like these ones, but in that case, those modules will have a slot for the SIM card. We will put the SIM card in it, and then they will work. But the focus of our work is to use the non-licensed ones, so we don't have to take licenses, or we will not take licenses, but we will need SIMs. For the SIM, there will be some financial package, the data package, and all these things. So that is an extra hassle. If you want for the students to create a low-cost setups or systems, or just give a concept of the system, Bluetooth, Wi-Fi, and LoRa are more than enough. So if you have some questions, Mr. Hussam is here. You can ask him in Arabic as well. Otherwise, after 1 or 2 minutes, I'll move to the cloud side of the Internet of Things.
Hey, yes, Afwan.
Okay, so moving on. What happens when this data is received on the server? We discussed a case study of a ThinkSpeak server. This is a free service for everyone. Anyone can register, connect his devices with it. His Raspberry Pi or Arduino. Arduino has its API available. You can just easily embed it in your programs. You can just connect a sensor or a two and start getting the data. The ThinkSpeak server has a database facility available. You can make your dashboards. The best thing about it is it has MATLAB API. So whatever data is stored on your online platform, you can easily access it using MATLAB, and then on the MATLAB you can run your analytics software, your prediction software, your AI softwares, or your AI algorithms to perform some operation based on the data which is coming into this database. because you need a lot of data, so that will be coming from your sensors. It will be stored in the, or we can perform the data aggregation functions at the server, and from there on, because now the data is on the cloud, you can either allow some create apps to connect with this data and see the, like for example, a chart or a visualization techniques, or you can use it to read it in a MATLAB and then perform your data analytics or predictive analytics or stuff like that. So the basic thing is, it is a free server. It will give you an opportunity to connect with it, and from there you can store your data. This data can be used, and also it will give you the reverse option as well. You can send a command from the server to the device as well, from your phone and stuff like that. So this is the ThinkSpeak complete website or a server which you can use for your application. You can access it, you can explore it. If you have some problem with setting it up, you can get back to us and we can help you out in this as well. What is the second part, which we already discussed, is it is the storage. All your data which is coming from your, for example, you can see the kids east room, kitchen temperature, solar temperature, all the temperature data is coming using the node ID, using the description, and then we are storing it, and it will have some data stored in it, like the temperature, centigrade values, and then from this data we can. So basically, on your server side, you have the data aggregator, the data cleaner, which will receive all the data, clean it up, store it in a database, provide it to the dashboard, and then you have the opportunity to have a user interface connected to that server. This user interface can be on your phone, on your device, on any other thing, from where you can also, instead, like not just getting the data, but you can also control that node and send some input to, and also you can observe the data. You have used these interfaces in like smartwatches. Every smartwatch has an interface like this. It gives you the overall view of all the devices, which is all the sensors which are connected with your smartwatch, the jogging data, the heartbeat data, oxygen data, all these things. This is for a smart home. You have different things you can, like fan and temperature monitoring and AC and all these things. You can control them, and of course you will send the data to the server. The server will communicate with the 8266 Wi-Fi module, and it will ask the microcontroller and on to the relay. Visualization is another feature at the server side. You can visualize your data, based on that, perform some sort of operations and all these things. But normally in IoT cloud services, we have these features available. You can plot your data of any sort, of any sensor, of one sensor of a node or two sensors. A single node can have more than one sensor. So you can have the data of all the nodes. And then we have dashboards. Dashboards are up to us. However, according to the applications, they vary from one application to the other. For example, this is a dashboard for CPU speed and the server. How much is the data available? What is the RAM usage and all these things. This is one sort of dashboard. This is another dashboard. For example, this is for the GPS data of Kareem or Uber or some sort of thing. If a company has some cars, it can show what is their fuel, what is their speed, what is their location. So they can have a look at all their fleet at any time. Okay, this device is at this place. Also, there will be some like temperature data or anything, the graphs, and so this is a sort of a dashboard which any server will provide you, or you can create your own dashboard. Once you have the data in the columns and rows, you can just easily read it and perform, like create a graphical user interface for it. MATLAB gives you like this dashboard interface as well. You can create in MATLAB, you can create it in LabVIEW, you can create it in a million of other software packages. But the basic thing is you need to have a connectivity to the server so you can display the data. This is another application for the like an energy consumption, temperature, weight. All these things are coming in a centralized database. So a dashboard. So this is for visualization of the user only, because it has nothing to do with other devices. This is only for, this is one feature that is there for the application which is provided by the server side of the Internet of Things platform. And the basic thing is you can have a dashboard in any form, in any factor. You can have it like the Iron Man, and you can take any sort of inputs and display them on different type of holographic screens or LCD screens or whatever you want, on a big screen or whatever. What are some of the potential IoT applications where it can be used? Most of the common one which we have seen is the smart home or electronic devices control. To reduce the power, we can turn off the devices at fixed times or like monitor their usage. In retail, you have seen them in payment gateways, in inventory control. But these things are smart devices. They are not connected yet to each other. But the only thing remaining is to connect them in a single internet. Medical, you have wearable devices, you have medical implants getting started, telehealth in which you can have operations remotely from a doctor which is not in the same location. We can have a lot of military applications like scanning the remote areas. We don't have to send a person to the border. We can remotely sense all the stuff at the border without having to have a soldier over there. Drones are another application. In the industry, we have smart meters, we have smart manufacturing. In automotive, we have like empty parking slots, we can detect them. Environmental concerns or the environmental applications are related to species tracking, detecting some animals or the endangered animals, then having tracking their movements and their presence or their population, then detecting the pollution levels, the air quality index of a city, stuff like that. And in the agriculture, of course, smart agriculture, in which we have moisture control, different water pH level control, which fertilizer to use based on the data from the sensors, and then smart irrigation, in which we want to only give water to the plant, only not just flood all the area to save water. So basically, smart irrigation systems. All these are some of the applications. And in context of a smart city, most of them, the applications which we discussed, they are already like they find their places in the smart cities, like pollution monitoring, animal farm monitoring, like the cow, fish, or goat farm monitoring, your fleet monitoring, in which you want to know where are the cars, where are my fleet, when something will be delivered, intelligent shopping to deliver stuff automatically or to shop stuff without needing to pay at the checkout or section, or all the different stuff, automatically detecting emergencies, accidents, fires, and all these things. So these are the some of the applications from where we can collect the data. They are all around us. We just need to have a breakthrough. We need to think of an idea to automate that process, and that can be a very good product in the future. Hussam will give you a brief introduction of the scope of Internet of Things according to the vision to 2030, and what will be the future and what the future holds, and then I will just summarize it and close today's workshop in a few minutes. So over to Hussam.
تقريبا قبل حوالي سنتين من الآن أطلقت المملكة مبادرة اسمها مبادرة تطبيق مفاهيم المدن الذكية في المملكة. كانت تهدف هذه المبادرة إنه بالحلول نهاية عام 2020 يكون عندنا في المملكة 5 مدن ذكية، لكن مع كورونا والصارت أتأخر العمل شوية، لكن ما زال جاري. والهدف إنه يكون بنهاية عام 2030 يكون عندنا 17 مدينة ذكية. وهذه المبادرة حددت إيش هي مفاهيم المدينة الذكية، إيش الأشياء اللي تخلي المدينة تبعك ذكية، وحددت الأمور هذه اللي أمامكم. المباني ذكية، أنظمة النقل تكون ذكية، خدمات الأمن والسلامة تكون ذكية، منتزهات وممرات تكون مزودة بوسائل التواصل شبكات ذكية لتصريف المياه والأمطار والسيول، استخدام إنارة ذكية للشوارع لترشيد الطاقة، أنظمة مراقبة تدوير النفايات، سرعة الاستجابة للطوارئ، الاقتصاد الذكي الداعم للشركات الصغيرة والكبيرة. وأيضا القطاع الخاص بدأ يشتغل في هذا المجال، إنترنت إنترنت الأشياء، يعني شايفين أمامكم زين وموبايلي وكذا شركة بدأت تعطي حلول للمشاكل الموجودة في الجهات الحكومية أو المصانع، وكيف تسهل عليهم أمورهم وحياتهم باستخدام إنترنت الثينكس. طبعا عشان ينفذوا هذه الأشياء هم محتاجين لمهندسين، محتاجين لمبرمجين يكونوا على علم بهذه الأمور. فأنت كطالب في كلية الحاسب الآلي، إذا عندك مشروع تخرج أو مشروع بحثي واشتغلت على الإنترنت اوف ثينجز، كان مشروعك عن الإنترنت اوف ثينجز وطبقت عليه ورحت لهم بعد ما تتخرج سويت مقابلة شخصية معهم، يكون في السي في تبعك مشروعك التخرج كان في الإنترنت اوف ثينجز، هيكون نقاط عالية يعني مسجلة في السي في تبعك. وزي ما ذكر لك محسن في بداية المحاضرة إنه عندنا هنا في كلية الحاسب بننشئ طور إنشاء، يعني نعمل مزود إنترنت اوف ثينجز. دكتور ماجد عميد الكلية طلب بعض السنسورز اللي شفتوها في البداية مع وبعض الأردوينوز والراسبيري باي تكون متوفرة لكم لطلاب كلية الحاسب الآلي. هي موجودة عندنا تقريبا راح تصل من شهر 11 راح تصل نهاية شهر تقريبا نهاية الشهر بعد أسبوعين من ذا. يعني عندكم تزورونا في الكلية وتلقوا نظرة عليها تشوف إيش ممكن تسوي بها في مشاريع التخرج، بالذات إذا أنت في مشروعك لسه ما بدأت مشروع التخرج عندك، وممكن تستفيد من هذه الإنترنت اوف ثينجز ويكون رصيد جميل لك في السي في تبعك. هنا بعض الأمثلة، راح نشوف أمثلة فعلية مطبقة على الإنترنت اوف ثينجز. أول مثال مشهور أكيد الجميع شافه، والسمارت هوم. سمارت هوم الفكرة الأساسية إنه يكون كل شيء عندك في المنزل مرتبط بالنت وتتحكم فيه من عن طريق الجوال أو الآيباد أو التابلت اللي عندك. تتحكم في باب الجراج، في لمبات الغرف، تتحكم في التلفزيون، في المكيف، في الثلاجة، درجة حرارتها وقوة الإضاءة. أي شيء في المنزل يكون متصل بالإنترنت. كل شيء في المنزل يكون عندك متصل بالإنترنت ولو IP تتحكم فيه من جوالك. هذا سمارت هوم، وهذا أساس إنترنت اوف ثينجز. مثال آخر كمان مطبق حاليا، يعني مثال شوية مضحك، سمارت إيج تري. يعني أنت حاليا في السوق جالس تتسوق وما تدري كم طبق بيض، تحتاج عندك هذا السيستم يعطيك كم بيضة عندك في الثلاجة، هل يصير تحتاج تشتريها ولا لا، وممكن تزور الرابط يكون موجود بالأسفل تحت وتشيك ونوصفه مع السيستم. أيضا تطبيق آخر لإنترنت اوف ثينجز سمارت واشنج ماشين، غسالة ذكية تتحكم فيها من جوالك أو تابلت، تتحكم في درجة حرارة الماء، في نوع الغسيل، متى تنتهي الغسالة من الغسيل. زي ما انتم شايفين الرابط في الشاشة، يمكنك زيارته عشان تتأكد من الموضوع. مثال آخر سمارت لايتنينج، تطبق وتستخدم التابلت اللي معك أو الجوال للتحكم في الإضاءة في الغرفة، شدتها قوية ضعيفة، تتحكم في كذا غرف أو تتحكم في البيت، إضاءة البيت كامل. مثال آخر أيضا سمارت AC، هو المكيف الذكي، تستخدم جوالك أو تابلت إن تتحكم في المكيف، تفتحه وتشغله، تشيك على درجة الحرارة وتضبط الإعدادات تبعه، وإذا في مشكلة أو يحتاج له صيانة نفس الجوال ترسل طلب صيانة زي ما شايفين نفس في الرابط برضه، إذا تشتوا تصوروا وتدخل عليه تجرب. هذا مثال آخر سمارت سليب سيستم. هذا السيستم يراقب تصرفاتك وتحركاتك أثناء النوم، يشوف كم مرة تصحى، كم مرة تمسك فيها الجوال، عشان في النهاية يكون عندك تقدير حلو تعرف في أنت شو تسوي أنت نايم. أيضا مثال آخر للتطبيق إنترنت اوف ثينجز سمارت ويذر ستيشن. يكون عندك على جوالك مراقبة للجميع، مراقبة للطقس، درجة حرارة الطقس، الرطوبة، ثاني أكسيد الكربون، الأكسجين الموجود. وزي ما انتم شايفين أسفل الشاشة في رابط يمكنكم زيارته. مثال آخر سمارت سلو كوكر، يعني جوالك أو من ثابت كده يتحكم بهذا الجهاز، جهاز الطبخ، تعرف كم درجة الحرارة فيه، المدة الباقية له عشان ينضج. وفي الرابط زي ما انتم شايفين موجود تحت. أيضا مثال آخر سمارت جاربيج كانز. هذا الجاربيج كان سمارت بحيث يكون موجود فيها سنسور مثل الليبل اللي وصلته النفايات، بحيث إذا وصلت عند ليبل معين تقوم ترسل إشارة للموجودين في البلدية بحيث إنه يجي يفرغوها. الرابط كمان موجود عندك. آخر مثال عندنا اليوم سمارت أجريجيشن ويستخدم في الزراعة، بحيث السنسورز في بعض السنسورز اللي تقيس الرطوبة أو مستوى رطوبة التربة، من خلالها تعرف هل المزرعة اللي عندك تحتاج إلى ري وبدون استعمال العملية أوتوماتيكية بدون تدخل الإنسان. كده نكون وصلنا لنهاية المحاضرة تبعنا، فأسيبكم مع المهندس محسن يتكلم شوية عن ما يخفي المستقبل للإنترنت.
So you saw some of the applications. The next one can be your application. Please don't forget to automate the gas cylinder, which I told you. So maybe next time when we show them here, it will be your application over here with some automated anything which will be converted into an Internet of Things. So what the future holds, as I told you, so far we have smart things which have some applications on our phones, on our PCs, on our servers, but the problem is they are all independent of each other. They are working separately. There is no interconnectivity. The things around circles is the place where we want to have user experience which is something based on all the applications, all the user equipment or the devices communicating with each other, to have an immersive experience so people can like enjoy only. They don't have to deal with each and every app. The app should be removed. There should be a common stuff in this place, or a common device in this place, or a common middleware application which can deal with all these data and just provide us with the meaningful information. Some companies have started working on it, like for the home only, not for the industrial application. You would have seen Amazon Echo, the Alexa, then we have the Google Home, which will try to connect to all the smart applications in your home. We have Apple Series speaker as well, which will connect with Apple IoTs and connect with them and give you a feedback on what is the temperature, what is the power consumption level, and all these things. And Microsoft is also in the same. with their invoke container. So with all these applications, what the companies want to achieve is to have a unified experience of all these apps. So you don't have to check your smartwatch application separately, your smart air conditioner application separately, your smart car application separately. There should be an interactive interface which can deal with all these things and just provide you on the screen or on a display all this information perfectly. And so far only one person was able to do it, and that is Aaron. So thank you very much, and we will see you in our next presentation some other time. If you have some questions, you can ask them now. You have my email and Mr. Husam's email available as well. You can write to us if you want some help with your smart solution, or if you have an idea, you want to prepare a solution for that, we can help you out. If you need some equipment, transmitters, receivers, sensors, actuators, we have a lot of them now. So if you need something from a solution, or if you need a training, if you want to learn about some things, you can just write to us and we will get back to you. If you have some questions, you can tell us.
Thank you very much, Dr. محسن and Dr. Murad. I mean Hassan, sorry. اللي عنده أي أسئلة يتفضل يسأل. يبدو إنه ما عندنا أسئلة. نشكركم دكتور محسن ودكتور حسام، معلومات جدا مثرية. إن شاء الله لنا لقاء آخر. شكرا.